Hey, what's up? We're going to look at gas pressure. This is a really easy part of P1. It's very, very simple. So imagine we've got a balloon, and inside there's loads of gas particles. And we know that there is a pressure inside this balloon. But what causes that pressure? And it's very simple. Pressure is caused by particles of air colliding with the walls of the container. It's not caused by the particles colliding with each other. You must say it's the particles colliding with the walls of the container. So every time one of these particles, or many of these particles, collide with the walls of the container, the particles exert a force on the wall, and that force divided by the area creates the pressure. So it's very simple. Pressure is caused by particles colliding with the walls of the container. The more often you have collisions, and the greater the force they exert, the greater the gas pressure. There's a couple of factors that affect it. The one you must know about the most is temperature. So you can see in this graph, we've got a graph of pressure versus temperature. And you can see that pressure is directly proportional to temperature. As the temperature increases, the pressure increases. And that's because at low temperatures, the particles are moving very slowly. They're moving all randomly in all different directions. But then as you start to heat this gas up, these particles move faster. They gain more kinetic energy. And because they have more kinetic energy, they collide with the walls of the container more often, and they collide with more force. So because there's more collisions of the particles with the walls of the container, the pressure increases. So as you heat a gas up, the pressure will increase. A second factor is if you just blow more gas into a container. So you imagine blowing up a balloon with more gas particles, you're increasing the number of particles within that container. And you can see here that the pressure, again, is directly proportional to the number of particles. If you double the number of particles, you will double the pressure. And it's quite easy to see why. We know that pressure is caused by collisions of the particles with the walls of the container. So if you have double the number of particles, you're going to have double the number of collisions of the particles with the walls of the container. Finally, volume has the opposite effect. If you decrease the volume, then the pressure increases. But when you increase the volume, then the pressure goes down. We say that the pressure is inversely proportional. Inversely proportional means that as the volume increases, the pressure goes down. In this picture here, you can see that we've decreased the volume. By decreasing the volume, we've got the same number of particles in a smaller volume. Therefore, the pressure is going to increase because there's going to be more collisions of these particles with the walls of the container per second when there's less space for them to move around. So, in summary, gas pressure is caused by particles colliding with the walls of the container. When you increase the temperature, the pressure increases because the particles have more kinetic energy. Therefore, there's more frequent collisions with the particles and the walls of the container. When you increase the number of particles, there will be more collisions with the particles and the wall. Therefore, the pressure will increase. But when you decrease the volume, then the pressure will increase. Pressure is inversely proportional to volume. And that's it. Thanks for listening. See you all soon.